in progress.
So today we are going to talk data representation and interpretation. So from this lesson you actually get two questions for your orders, from data representation and interpretation, also from frequency distribution. So the frequency distribution part will be in the second paper. We will be discussing questions from the first paper, right? Namely histogram, frequency polygon. In the first part of the session, we'll be talking about histogram and frequency polygons. Okay. See, I'll take a single example to demonstrate what histograms and frequency polygons. Some technical issues.
Let's see. Recording in progress.
Let me know if you guys may have an idea about frequency and class intervals. Do you guys have a rough idea about frequency and class intervals? Yes. Okay. So for those who don't, I'll give a small example. Consider students in a class. Consider a set of students and their weights. The weights, right? So there can be around 30 to 40 students in a class, and I can break their weight into ranges, like from 50 kilos to 60, and then 70 to 80, 60 to 70, likewise. So the ranges of their weights, those are the class interval. So simply a class interval is a range of values, 60 to 70, 50 to 60, likewise. And the frequency is how many students exist in the range 50 to 60 kilos. So for example, if I say 7 students weigh around between 50 to 60, so 7 is the frequency of this distribution. So 7 is the frequency and the range is the class interval. So I guess this is clear, class interval and frequency. So this is the very basic thing for the lesson. Right? Without this we can't move on. So I just gave you a rough idea. There are no deep theories in this lesson. Just you will have to know how to plot a graph and mark data. That's it. Okay? So I'll consider an example. Let's take fish. Right? Fish and their weights. So I'll take weights here, weights in kilograms. And then here number of fish. Let me know the number of fish here. Is it a class? Will it be a class interval or frequency? The number of fish. Yeah, number of fish will be a frequency, right? How many fish are there? So, for example, if I say from 0 to 10 kilograms, from 0 to 5 kilograms, there are 3 fish, and 5 to 10, there's 7. 7. And then 10 to 15, there's again 4. 15 to 20, there's 5 fish. So this is how they'll be giving you the question in the example. Right? Sometimes they'll have some blanks here. They will see how to fill those blanks. Before that, you will have to understand how to interpret this data. Right? The lesson is entirely data representation and interpretation. So interpreting something means understanding. So you'll have to understand this data and you have to represent it in a histogram. So a histogram is nothing but a Cartesian plane. You may have come across Cartesian planes, right? X-axis and the y-axis. So in the y-axis, there's always frequency. Remember, in every graph in this lesson, the y-axis will be frequency. So if the y-axis is frequency, what would be the x-axis? Yes? Yeah, the x-axis would be exactly class interval, right? Class interval. So always like they give you the graph and you have to just draw the histogram, but you need to know the basics. Always the y-axis is frequency and the x-axis will be class interval. So we can mark class intervals. It starts from 0 and see what is the size of a class interval. What is the gap between every class interval? What is the size? Yes. No. The size is how to get the size of a class interval? Okay. See, there are two parts in a class interval. This is called the upper limit. This is called the upper limit, and this is the lower limit. So if you need the size, you will just have to subtract the lower limit from the upper limit. 5 minus 0. What is the size? The size is 5, right? Here, 10 minus 5. What is the size? Yeah, again 5. Okay. So the size of class interval is always 5. So we can put even sizes 5, 10, 15 and 20. So what we are doing is we are just reading this table. We are trying to understand this table and we are going to represent it in a graphical form, like in a graph. That's it. So this is similar to a bar graph. See, between 0 and 5, how many fishes are there? 3. That's 3 fish. So 3. We mark 3. Like we can mark the frequencies like this 3, 4, 5, 6, 7. And there's 3 fish. Between 5 to 10, let me know. Between 5 to 10, look at the table and just type. How many fish? Yeah, between 5 to 10, there's 7 fish, right? You can clearly see the table here. You see the table and then you mark it. Between 5 to 10, there's 7 fish. And between 10 to 15, there's 4. So this is 4, right? It's 4. And 15 to 20, that's 5. Are we clear? Like how to mark a histogram? Like this is the very basic form of a histogram. Histogram can be complicated, right? This is the easiest form. Okay. Yeah. So, and after marking the histogram, it's better if you note down the values here, like not for the ease of the marking examiner. It's for the easiness of you, because they'll be asking further questions from this histogram in the exam paper. So I put a PDF, right? So in that PDF we have one question regarding histograms. Let's try it. Before that, like we'll do another example. So this is the histogram. This is a very basic form of a histogram. And after drawing the histogram, on the histogram we can draw the frequency polygon on the histogram. So we are going to see how to draw a frequency polygon on the histogram. So that is also simple. Let's see. We drew some rectangles, right? We drew some rectangle. So on the top of the rectangle, there's always a midpoint. See, here 0 and 5. Let me know the midpoint of this. Yeah, the midpoint of 0 and 5 is 2.5, right? 2.5. So you don't have to mark 2.5 here. Just roughly put a cross, right? Put a cross. And then on the next rectangle, between 5 and 10, what would be the midpoint? 7.5, yes. So you just mark crosses on the midpoints of the rectangles. Are we clear? So we are done with the histogram. We are now going to draw the frequency polygon. So the only mark some crosses on the exact middle of every rectangle. Is it clear? That's clear, right? Yeah. I've been getting messages. Wait a minute. This one, upper. Yeah. Give me a second. I'll explain this after we finish this. Right. Okay. So everyone is clear with marking the crosses, right? So a polygon, like since small age, you know what a polygon is, right? A triangle is a polygon. Pentagon is a polygon. So a polygon is a closed figure. So see, if we join this process, do we get a closed figure? We don't get a closed figure, right? We just got some straight lines. So in order to obtain a closed figure, we have to end this and start this. Like here, that's 20. What would be the next point? 25. You have to put a cross in between 20 and 25. So you can close the polygon between 20 and 25. Right? So before the beginning also you must do the same. Here 0 to 5. So what would be here in the number line? 0, 5. What would be this interval? Yeah, that's -5. So between 0 and -5, you will have to put a cross and close the figure. Now this is a polygon. See, this is a closed figure now. You can see, right? So this is how frequency polygons are made. Why marking in between? So otherwise we cannot make a polygon here. So that's how we are taught, right? So see, this is a histogram, and we have to construct a polygon using this histogram. If we don't mark in the midpoint, like you try marking otherwise and see if you can make a perfect polygon. You can't. So always we have to mark in the midpoint and then join the process. So the thing in red color is the polygon, the red color stuff, that's the frequency polygon, and the blue color thing, that is the histogram. Are we good with histograms and frequency polygons? Yeah. So upper limit and lower limit, I'll explain again. Every class interval, like a class interval starts with a number and ends with a number. So here we can see there are 3 fish weighing between 0 and 5 kilos. For example, 1 kilo, one fish may be 1 kilo, another one may be 5 kilos. This is less than 5, sorry. So another one may be 4 kilos and another of 3 kilos. Likewise. So the upper limit is 5, like before the maximum. And the lower limit, the minimum is 0. So these are just terms used to define the two numbers, the starting and ending points of a class interval. So you don't have to take that into consideration like up to a great extent. Just you have to understand this, right? Yeah. So one example is done. So we have another 2 examples, and then we can move on to the cumulative frequency. I'll give you a table. The same fish example, but data is different. See, class interval and frequency. This is weights, and the frequency means number of fish. Let's start from 10 to 15 kilos. That is, say, 4 fish. 15 to 20. We have 5. 20 to 30. We have 6, 30 to 35. 7 fish. 7, 2, 3. Let's see. So, same like before, we'll have to construct a histogram. We have to construct a histogram. Let's see. Let's try constructing a histogram. So, are we going to start from here now? Are we going to start from here? No, right? Because the intervals start from where? They start from 10. So, we can do something. For example, if the interval started from 50, suppose the first row of this started from 50, are we going to mark 0, 5, 10 up to 50? No. We can do something like this. We can shrink the x-axis, which means every number between 0 and 50 lies here. Like we can start from 50. No problem. Yeah, I'll come to that. I'll come to that. 20 to 25, like 20 to 25 is missing me. Alright, I'll come to that. See, let me know if this is clear. If they give you a class interval like 50 to 55, you can't, that's not practically, you can't mark from 0 to 50. So what we do is we shrink the axis and we start from 50. Is that clear? So here we can shrink the axis and start from 10. We can start from 10. 10 to 15. Always mark the class intervals in the graph in the same gap. So 10, 15, 20, 25, 30, 35. Right? Same gap. And then see how many fish are there from 10 to 15. Let me know. From 10 to 15, yes, that's 4. 10 to 15 is 4. So we can mark like this. 10 to 15, that's 4. 15 to 20. 15 to 20. Yes. 15 to 20 is 5. 15 to 20 is 5. And then now we have a problem. See, is there 20 to 25? Does that exist? 20 to 25 doesn't exist. They have straightly jumped to 30. So what we can do here is, we don't know 20 to 25, but we know 20 to 30. We can distribute this number evenly to both the intervals. So we have 6 fish. How many can we give to this range? If we distribute evenly, yeah, we give 3 fish here and another 3 there. So we don't mark 6 here, we mark 3. See, here's 3 fish and here's 3. What's the total amount of fish? That's 6. Is this clear? That's why I didn't put 20 to 25 to make you guys understand how it's done. Is that clear? We don't mark 6 fish here. That's a major mistake some of you guys do. The class interval is twice the normal class intervals. So we have to divide this number by 2 and evenly put. And then 30 to 35 as usual, there's 2 fish. So we mark 2, 2, 38, 5 and 4. Is this okay? Won't we draw a line in the middle to? No, we never draw a line in the middle to separate them because they haven't separated it here. That's the reason. Right? We consider this as a single class interval, but we decrease the height because we evenly divide it. We don't draw a line. Okay. Are we clear? If you guys have any doubts regarding this, please let me know. All clear? Okay, good. So now they say draw the frequency polygon. Okay, I'll do this once more. Let's see. Like I'm not gonna draw it once more. I'll try to explain. See, look at the sizes of the class intervals. The size here is 5. Here also 5. Here it's 10, right? The size of the class interval is 10. There's a problem. Here is 5. That's cool. Now, as usual, we are trying to draw this. Okay, 10 to 15, we have 4 fish. So we can mark 4 fish in 10 to 15. And 15 to 20, we got 5. That's done. And then 20 to 30, there comes the problem. We have 6, but we can't mark 6 here. Because if we do that, we are violating the rules of a histogram. In a histogram, you must evenly separate the data, separate the frequency. So we considered 5 as the general class interval, right? 5, 5. So you must do it here also. So if you have 6 fish, you got 2 intervals here, right? You pass 2 intervals here. Is that understood? You pass 20 to 25 and then you pass 25 to 30. So you will have to divide the 6 fish by 2. 3 fish to this side and 3 to this side. Exactly. So for example, if we got 10 fish here, what will you do? 5 to this side and another 5 to the next. Yeah, 5, 5. Yes, exactly. So that is it. And we can draw the frequency polygon as usual, no changes. Before 10, there's 5. So between 5 and 10, we put a cross. Between 10 and 15, we put a cross. Between 15 and 20, a cross. And then between 20 and 25, that's a must. You must put a cross. And then 25 and 30, again a cross. 30, 35, done. And finally, to close the polygon, we do 35 to 40, another cross. And see, we join the process. So this is the procedure. Yeah, these 2 crosses are must. And here also, 2 crosses are must because we divided it into 2 sections. We divided this class interval into 2 sections. Right? For example, let me know, they give another class interval like this. How many sections do we divide this into? They give a class interval like this and give us a number something like 12. Yeah, we divide this into 3, ne? Exactly. Seems like you have understood. See, here we divide it into 2 because there are 2 5s. Here there are 3 5s, 15. Ne? So we divide it into 3 and then 12, we can divide 12 also by 3. So 4, 4 and 4, like this. Okay. We can divide this frequency and draw these two. So as simple as that. You can score full marks for this question without a doubt for histogram and frequency polygon. So and this is a compulsory question in your levels. So try to do this. And then we have the cumulative frequency curve. That's a bit of a theoretical part. Before moving on, try the question in the PDF. Try the third question. I'll give you 5 minutes. 5 minutes, yeah, that's more than enough. Try the second question. Sorry, 2019 order. 2019 order. Try it and let me know in the chat if you are done. If you can't put answers neither because we'll have to draw a graph, so you can't send graphs in Zoom chat. A full paper, like I forgot to mention about the paper sessions. We have finished one paper session. The attendance was pretty good. There were around 30 students. You guys can join us. When we forward the post in the group again. We are done with one. We have 2 more sessions to go. Full papers. Correct. So the papers are prepared by myself, and a marking scheme, a detailed marking scheme will be provided. So you can join and see for yourself. Okay, try the question 2019 and let me know if you're done. Yeah, and guys, I guess we won't be able to finish cumulative frequency today. So may allocate it for the next session, right? Let's finish histograms and polygons today, and also I'll try to finish quartiles. In the next session, we can finish the lesson cumulative frequency. Okay. Okay, some of you have done already. Guys, can see my screen, right? Yeah. So, shall we discuss, or you need more time? Okay, let's discuss. See, the following incomplete frequency distribution and corresponding incomplete histogram. See, there's a histogram which is incomplete and also a table which is incomplete. Have been prepared using the marks obtained in a test by 40 students in a class. Here 10 to 20, so this range denotes the marks greater than 10. So 10 to 20 means greater than 10 and less than or equal to 20. So that's pretty understandable, right? There's nothing complex in that. 10 to 20 means marks greater than 10 but less than or equal to 20. That's the range. And the other intervals denote similarly. Good. So let me know what is the smallest interval. What is the smallest size? What is the size of a class interval? Yeah, the size is 10. Eh? So the best thing here, we can start marking in the histogram, marking the numbers. So it's 6 here. What's the number corresponding to the next one? 4. So here it's 4 and here 4. So let me know the number of students between 20 to 40. How many students are there between 20 to 40? Exactly. That is 8. Are we clear? Between 20 to 40, there are 8 students. Okay. And then between 40 to 50, what's the number? Yes, 40 to 50, it's 7. And then 50 to 80, they say there's 15. Let me know how many parts are there? How many parts are we going to divide 15 into? Into 3 parts, ne? Into 3 parts, yes. So that would be 15 divided by 3 is 5, exactly. 15 divided by 3 is 5. So you're going to mark it like this. See, so here's 5, 5, and 5, 15. And then 80 to 90, there's 4, ne? I'm not wrong, that's 4, yes, that's 4. So see if these add up to 40, 10, 25, and 40. So they add up to 40. I hope you guys got this right. Yes, it's pretty easy. Yes, okay, good. So we completed the histogram. Let's see what the next question is. Express the number of students who obtain more than 40 marks as a percentage. What would the answer? Let me know the answer. Okay, there's an answer saying 65%. Is that the answer you got? $26. Let's see. Let's see. They ask us to represent the students who obtain more than 40 as a percentage. Let me know the number of students who obtain more than 40 marks. How many students obtain more than 40 marks? Yes, that's 26. Ne? More than 40. See, more than 40. 40 to 50, there's 7. And 50 to 80, there's 15. And then another 4. So the addition would be 26. 26 students. So they are asking us to represent this as a percentage of the total. So 26 out of how many students? 26 out of 40 students. Yes, 40 students. So in order to denote this as a percentage, we multiply it by 100%. This is the rule. If you want to denote anything as a percentage, you simply have to multiply it by 100%. And you can cancel off. See, here's 0. And 4 divided by 4 is 1. Here it's 6.5. So 6.5 into 10. Yes, the answer is correct. That is 65%. Are we clear? They asked us to represent as a percentage of the total. That's clear? Is that clear? Yeah. Yeah, it's pretty simple. Like how to solve this. See, 26 out of 40 into 100. So we can cancel off a 0. And then we can cancel this by 2 if you need. There's 5 2's in 10 and 2 2's in 4. And again there's 1 2 in 2 and 13 2's in 26. So 13 times 5 is 65. I hope it's clear. The simplification someone had asked. Okay. Is there another question? They say draw the frequency polygon. Okay, let's come back to the screen. They ask us to draw the frequency polygon. So that's nothing, eh? Frequency polygon, just marking crosses. we mark across here, here, here. And between 0 and 10, another cross. So between 0 and 10 means that's 5. At 5, we mark a cross. And then we join these crosses. Can't you guys see the screen? It's visible, right? Yeah. If you can't see the screen, just tap on the there would be a small window if you are from mobile phone. So tap on it and you'll be able to see the screen. So I guess the frequency polygon is also clear. Okay. Yeah, the shared screen is. You are still in the shared screen. So you can see the frequency polygon, right? Do I have to repeat the polygon or is it clear? Clear. Okay, so after the frequency polygon, we have another 15 minutes left. We'll try to cover the quartiles. I'll tell you what a quartile is and let's see. So let me know if you have the idea of a median, if you know what a median is. Median of a data set. What is it in simple terms? Yeah, median is the number in the middle. Median is the data in the middle. If you, for example, if I write some data like this. Wait. What would be the median? Yeah. The answer I expected is there. Like that's wrong answer. I expected the wrong answer, and you guys have sent the wrong answer. Why is it? Like before analyzing any data set, we'll have to arrange it in ascending or descending order. Remember that. Correct? Always we have to arrange a data set in either ascending or descending order. So ascending order is more preferable. So what's the median now? The median is 5. Right? That's clear. So in any data set, you can say, if you said 4, that's because you didn't sort the data, you didn't arrange the data. So you will have to arrange the data first from small number to the largest number. Right? And then you can see the mid value. That's 5. This is the median. Are we clear now about medians? Yes, I guess. Okay. So, quartiles are simply something like median, right? But the name gives you the definition, right? What does a quarter means? Quarter means 1/4. Never. A quarter means 1/4. So in the median, that's half. Median means exactly half of the data set, the half place, the middle place. So quartile is, if I have suppose I have 12 data, I have 12 numbers. So the quartile means simply the fourth number. The first quartile is the fourth number. Right? According to your syllabus, the easiest way to remember quartiles is the table I have given you in the tutor. in the last page. Refer to it. Refer to the table. I'll put it here. So in that table, right, n means the number of data. For example, I'll give you some data. See, 2, 4, 5, 7, 3, 2, 1, 7, 4, 8, 9. Let me know how many data. This number is not visible. Ne? How many data I have given you? Yeah, I have given you 11. Ne? I have given you 11. So, is the number of data less than 30 or greater than 30? The number of data is less than 30. So, you can easily use these formulas. This set of formulas is not that hard to remember. Try developing a technique that's n plus 1 over 4, twice n plus 1 over 4, and thrice n plus 1 over 4. So, you will have to remember only one. Right? So, if the data is less than 30, are we referring the first column or the second column for the formulas? We are referring the first column. If the data is less than 30, we are referring this column, the first column. Right? Less than 30. So this is less than 30. Before analyzing data, we must arrange data in an order. So the best order is ascending. I'll write the data set here. In ascending order, that's 1, 2, 2, 3, 4, 4, 7, 8, 9. So that's 11 here. 1, 3, 9, 10. What did I miss? I missed another 7. So I erase the data now. Now I ask you to find the first quartile. How do we find the first quartile? See, and in brackets I have given you a term like place. Let's see what does place mean. Right? Let's see. N plus 1 over 4. What is n here? 11. So 11 plus 1 over 4. What is 11 plus 1 over 4? What's the answer? Yeah, 11 plus 1 is 12. 12 divided by 4 is 3. So, the first quartile is not 3. The first quartile is in the third place. I have given you the term place. Ne? So, the first quartile is in here. 1, 2, 3, third place. What is the first quartile? The first quartile is 2. Are we clear? Okay, let me find me the second and third quartiles of this data. The second and third quartiles. Yes, the second quartile is, they say the second quartile is 4. Let's see. The second quartile, the formula for the second quartile is 2 times n plus 1 over 4. We know n plus 1 over 4. N plus 1 over 4 is 3. So 2 times 3. 2 times 3 is 6. So in the 6th place, second quartile is in the 6th place. 1, 2, 3, 4, 5, 6. This is the second quartile. And the third quartile, 3 times 3. 3 times 3. Here is 3. 3 times 3, 9, 6, 7, 8, 9. The third quartile is 7. Are we clear? Yeah. If the data set is too large, for example, you have 40 data. If you have 40, so you can find the quartiles using this set. Right? That's kind of a rule in your O-level syllabus. According to like this lesson is a pretty like foundation for statistics. Have you ever heard statistics? That's a large branch of mathematics. So this is a foundation for the lesson. So you don't try to argue or like you can try to find out why we do such stuff, but that's not necessary for the O-levels. Correct? Why we use a different set of formula for numbers less than 30 and greater than 30? That's because your syllabus is designed that way. Correct? Your Sri Lankan O-level syllabus. Correct? So, can't you see something special about this second quartile? What can you say? That there's something special here. See, the second quartile is exactly in the midpoint of the data. Eh? So the second quartile is also what? The median. The median is known as the second quartile in any data set. The median, there's another name for the second quartile, that is the median. So this is special, and Q1 and Q3 are normal quartiles. So from this formula, you don't get the direct answer. From the formula, you get places, sixth place. So you must count. You must count and see what data there it is. See, the second quartile is 4, and it is in sixth place. Is it clear how to find quartiles of a data set? Okay, let me know if you know the meaning of the word range. What's the meaning of the word range? In grade 9, you have studied this. In grade 9, frequency distribution, you have studied the word range. What's the meaning? The range of a data set. The highest value minus the lowest value. Range means the highest value minus the lowest. Correct? So in this data set, normally if I ask the range, it is 9 minus 1. Are we clear? Yeah, the range of this data set is 9 minus 1. So there's a special range, interquartile range. Interquartile range. So that's simply the range of quartiles, which means the highest quartile minus the lowest quartile. So what is the interquartile range of this data set? The highest quartile is always Q3. So interquartile range is Q3 minus Q1 for any data set. So Q3 here is 7, Q1 is 2, 7 minus 2 is 5. This is the interquartile range. Interquartile range, is that clear? Yeah. So we did histogram, frequency polygons, and quartiles. Before ending the session, try the question in the last page, the very last question. The number of members in a family. That one. I'm sharing the screen right now. Hope you can see that. The number of members in a family. Families of students is given below. Try finding the median, first and third quartiles, and also the interquartile range. And you can send the answers via the Zoom chat. Okay, few people have done. Shall we discuss or you guys need more time? Okay, I'm receiving answers. Let's see. Okay, I arrange the data in ascending order. First, they are asking us for the median. Let me know which quartile is the median. Yeah, median is Q2. And the number of data here, how many numbers are here? What is N? The number of data here is 15. Eh? Yeah, that's 15. So that is definitely less than 30. So we must use this thing, N plus 104 into the quartile number. Right? Okay. That's it. They're asking us for the second quartile. So N plus 104 into 2. That's the second quartile. So N is 15. So we need 2 times 15 plus 1 over 4. So 2 times 15 plus 1 is 16. 16 over 4. So that's 8, ne? 8th place. The second quartile or the median is in the 8th place. Let's see what is in the 8th place. 1, 2, 3, 4, 5, 6, 7, 8. This is the second quartile or the median. Are we clear? The second quartile. And then Roman number 4, we are done. We are done with Roman number 1. The second quartile is 5. And Roman number 2, they are asking for the first quartile. First quartile is simply N plus 1 over 4. N is 15. 15 plus 1 is 16. 16 over 4. That is 4th place. In the 4th place, we have 4. That is Q1. We have Q1 in the 4th place. That is 4. Correct? And then Q3. Simple. N plus 1 over 4 multiplied by 3. N plus 1 over 4 is 16 over 4. That's 4. 3 times 4 is 12. So it's in the 12th place. Let's see what is in the 12th place. 6, 7, 8, 9, 10, 11, 12. So that is 8. Q3 is 8. Are these clear? Is it 7? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, yes, that's 7. Sorry. Here, this is the 12th place. So Q3 is 7. Yeah, sorry about that. So that's 7. And then they're asking for the interquartile range. We know how to find the interquartile range. That is Q3 minus Q1. Q3 is 7 and Q1 is 4. 7 minus 4 is 3. Is this question clear? Yes. So time is up. Let's end the session for today and let's do cumulative frequency in the next one. Most probably the next session will be in daytime. Let's see. Good. Thank you for participating. God bless.